Greetings. In this lesson we are going to talk about slope and the concept of slope. Let's look at these four graphs. Each of these graphs is a graph of a line. What characteristics differ in these four graphs, these four lines? Well, the direction and the steepness of each line. Notice these three lines go up to the right. This one over here comes down as we go to the right. Notice that some seem to be more steep than others. This one seems to be more steep than that. This idea of steepness is an interesting concept. There's a flight of stairs. There's another flight of stairs. I'm sure you've climbed stairs in older homes where they tend to be much more steep. And some steps, particularly in the front of buildings, Capitol buildings, seem to be more shallow. That's the steepness. And in math, we call that slope. We can also think about roofs. You've seen the pitch of roofs. Some roofs have a pitch like that, which is quite steep. Some roofs have a very shallow pitch, like that. And some roofs are flat. Again, that's another practical example of steepness, or what in math we're going to call slope. Steepness is a good synonym for slope, but slope will also take into account direction. Let's look at these four graphs. We have a runner. Here he is. He's going uphill. That's a positive slope. Goes in this direction, our slope is positive. Each one I'm drawing is more steep than the one before it. The slope is going to be greater. Let's look at this one. It's a line, yes, it has arrows on both sides, but it's going down as we go to the right. We can think of him as running downhill, okay? It can go down like that, it can go down steeply, it can go down more shallow. But all of these have a downward slope, which we are going to learn is a negative slope. Well, go out for a walk on flat ground. Are you walking a hill? Is there any slope to the ground? Here he is, walking along this line. We're going to find out that has no slope, or a slope of 0. How about a vertical jump? We're going to find out that this is undefined, and we're going to find out why. Now that we understand the idea of steepness and slope, how is slope defined and calculated in mathematics? Let's take a look. Slope of a line is indicated by the lowercase letter m. Very important, okay? Lowercase m represents slope. The slope of a line is defined by the rise over the run. Here's my rise, and here's my run. Rise over the run. Between any 2 points of your graph. Doesn't matter which 2 points. So, the slope should always be given in simplest form. We're going to reduce our fractions. So the slope is equal to the rise over the run. Let's look at this diagram, okay? Here we have the graph of a line. This is an equation that's graphed. We have a rise that goes from here to here and a run that goes from there to there. There are 2 points on that graph. We can take any 2 points. It doesn't have to be those 2 points. I could take this point and this point just as easily and do my rise and my run. But we always have a rise and a run between 2 points. The rise indicates a change in the y value. The run indicates a change in the x value. Let's take a closer look at this. Here we have the same graph. I've labeled my points, point 1 and point 2. The coordinates of point 1 are x1 and y1. The coordinates of point 2 are x2 and y2. Can we all see that the rise is going to be the y value change from here down to here, which is y2 minus y1. y2 is 3 and y1 is 1. The rise is y2 minus y1, which is 3 minus 1. Now let's look at the run. The run between these 2 points goes from here to here. By the way, you should see the Pythagorean theorem at work here, okay? This, of course, is a right angle. Here's the run. It's going to go from this x value to this x value. We're going to go from x2 to x1, which is 6 minus 2. Right here. And let's evaluate that numerator and that denominator, and we get 2 over 4, which is 1/2. The slope of this line is 1/2. If you think about it, you go up 2 and over 4. You could also look at this point. I go over 2 and up 1. 1 up to 2 over. A slope of 1/2. Let's look at a couple more. Let's take this figure A on the left. We have 2 points here, 1, 2 and 5, 7. And we want to calculate the slope. Slope is equal to rise over run. Drill that into your head, okay? y2 minus y1. Well, I'm going to take, this is point 2 and this is point 1. You need to be consistent, so it's a good idea to label them. y2 is 7 and y1 is 2. Now let's go to the run, which is x2 minus x1. This was point 2, so x2 is 5 and x1 is 1. Here we have 5 minus 1. Let's evaluate the numerator and the denominator, and we get a slope of 5/4. This is equal to our lowercase m. Notice that this line is a lot steeper than the last one, okay? If you were to go up and over, if you went up 1 over 1, you would follow the diagonal at a 45-degree angle with this line. That's up 1 over 1, up 2 over 2, up 3 over 3. All have a slope of 1. Anything less than 1 is going to have a more shallow slope. Anything more than 1 is going to have a steeper slope. Notice all of these that are drawn on this left side are positive slopes. They go up as we go to the right. Let's look at diagram B. We have 2 points at 2 comma 6 and 4 comma 3. I'm going to label this point 2, I think. And I'm going to label this point 1. It doesn't matter which it is. It might make the math a little easier, but it doesn't matter which you label 1 and which you label 2. The slope is the rise over the run. We're going to take the difference in the y's. The difference in the y's are y2 is 3, y1 is 6, right here. The difference in the x is always beginning with x2. x2 is 4, and x1 is 2, right there. Simplify your fraction and you get negative 3/2. Notice that 3 minus 6 is negative 3. We get negative 3 over 2 for our slope. Remember we showed you that slide? A negative slope goes this way. It's going to come down as you go to the right. Or you could say it goes up as you go to the left. Okay? Positive slope, negative slopes. Okay? A few notes for you to keep in mind. It does not matter which 2 points of a line you use to find the slope. Between any 2 points, you're going to find the same slope unless you make a math error. It does not matter which point you take as point 1 and which you take as point 2. The most common mistakes are mixing up the rise and the run and getting the change in the x on top and the change in the y on the bottom instead of the other way around, or switching between point 1 and point 2. Make sure you always start with point 2 here and point 2 here. It's very common. Someone will do y2 minus y1 and then x1 minus y2, x1 minus y2 instead of x2 minus x1. Those are the most common mistakes we find in slope. So the rule is be careful, okay? And that's all it takes. Let's look at a couple special cases. Let's find the slope of this line. Here are our 2 points. Can't really see that without some contrast, can you? Okay, this point is 2 comma 3, and this point here is 6 comma 3. The rise over the run. Well, what is the change in the y? y2, I'm going to label this 2, and I'm going to label this 1. y2 minus y1 is 3 minus 3. x2 minus x1 is 6 minus 2, and lo and behold, that comes out to a slope of 0. A slope of 0 is a horizontal line. Okay? So n equals 0. Let's look at this special case. Here we have 1 comma 4 and 1 comma negative 2. It is a line. y2 minus y1. Well, I'm going to take, what did they use for? I'm going to use this as point 2 and this as point 1. I'm going to take y because I'm going to take y2, which is 4, minus y1, which is a negative 2. Be careful of your signs or it won't come out right. 4 minus a negative 2. I'm going to go back up and take x2, which is 1, and x1, which is 1. We've got a problem here. Now that's enough to give a math teacher a heart attack. You should know, you cannot have a denominator of 0 that is undefined. The slope is undefined. Please do not say it has no slope. This has no slope. Or actually, it does have a slope, it's 0. This slope is undefined. If you remember our talk about functions, you should be able to answer the question, is this line a function? No, it is not. Is this line a function? Yes, it is. Here are 3 examples. I want you to freeze your movie and try these out, and I'm going to post the answers in a second. First one, it's all set up. You just have to plug in the numbers after you pick point 1 and point 2. Make sure you pick point 1 and point 2. I'll do the first one with you. I'm going to label this point 2 and this point 1. I don't know what they did at the answer key. But I'm going to take y2 minus y1, which is 4 minus 1, x2 minus x1, which is 6 minus 2, and I'm going to get 3 over 4. I want you to try the rest, and then I'm going to pop the answers up. There you go. I hope you did well. If you made some errors, please go back and find your mistakes. Usually they're with a negative sign, or the mistakes that I previously mentioned. And that's all I have for you on slope today.